Hello class, this is lesson 6-1 titled How to Solve Linear Systems by Graphing. So we're going to begin chapter 6 today, and let's just first of all talk about what a system of linear equations is. Basically it's just a set of two or more equations. Okay, they must be linear equations though, which means that they have an x and a y in them. And to find a solution for them, because that's what this section is how to solve them. So a solution for two linear equations is an ordered pair. Like x comma y. So some pair, some coordinate that you've already found. Okay, and so the way that we're going to solve these today is simply by graphing the equations and looking to see where they intersect, because that point where they intersect is going to be the solution for both of those equations, and then we're going to find out how to check that solution. So here is our problem that we're going to begin with. Okay, we're asked to solve this system, so I'm going to just cover up this bottom part for right now. And we're asked to solve two linear equations, and as you can tell, they're written in standard form right now. Now it's up to you whatever form you want to move those two equations into before you graph them. For me, it's kind of always been easiest just to graph them in slope-intercept form. So that's what I'm going to do. I'm just going to rewrite them. I'm going to subtract x on both sides of this one. So I get 2y is equal to negative x plus 7. And then when I divide 2 on both sides, I'm going to have negative 1/2 x plus 7 halves. Okay, so if I was going to graph this, I would start with my y-intercept, which is 7 halves, which is 3.5. So 1, 2, 3.5. And then I'm going to go down 1 and over 2. So I have that. I'm going to get my ruler and I'm going to connect these two dots. And there is my first line. So when you're doing this work in class, it's really important to use graph paper so that you're very accurate with your work. The second part, I'm going to rewrite this as well. So I'm going to subtract 3x on both sides. And then I have negative 2y is equal to negative 3x plus 5. And then when I divide everything by negative 2, negative 3 divided by negative 2 is positive 3 halves minus 5 halves. Okay, so this time the y-intercept is at negative 2.5, but the slope is positive. I'm going to go up 3, 1, 2, 3, and over 1, 2. Okay, so there we go. I'm going to connect my two dots to form my line, and there you go. So graphing should be pretty easy. We've done a lot of practice of this in the past. So now looking at where they intersect, kind of looks like they're intersecting at 3, 2, but I'm not entirely certain. So that's why the book is really great in having you check your work, okay, just to make sure that it does work out in the end. So all that we're going to do is we're going to plug in for x the number 3 and for the y the number 2 and see if it is a true statement. So 3 plus 2 times 2, is that equal to 7? So this is 3 plus 4, and yes, 7 does equal 7 there. So at least it works for the first equation. Let's see if it works for the second. 3 times 3 minus 2 times 2, does that equal 5? So 3 times 3 is 9, 2 times 2 is 4, and 9 minus 4 does equal 5. Awesome. So my solution is 3, 2. And I'm done. Okay. We're just going to do one more example today, and then we're going to be done. So here's the second one that we're going to try. Solve the system by graphing negative 5x plus y, which is equal to 0, and 5x plus y, which is equal to 10. So again, what we want to do first is we want to rewrite our equations so that it's really easy for us to graph them without any problem at all. So if you want to try to graph it in standard form, that's fine, but I'm going to rewrite them. And this time it's really easy to rewrite them. I just need to move the x to the other side. So the first one is going to be y is equal to 5x. Okay. If you want to put plus 0, you can, but I'm not going to. It's going to start at 0, and then I'm going to go up 5, 1, 2, 3, 4, 5, and over 1. And that is going to be my first line. And be really careful drawing this line. There you go. Awesome. And then my second one, again, all that I need to do is move the 5x over, so I'm going to subtract 5x. So this is going to be y is equal to negative 5x plus 10. So this time I'm going to be up at 10. And you may not be able to see that, but that's about where 10 would be. If you have graph paper, it's not going to be a problem for you. And then I'm going to go down 5 and over 1. Okay, so I'm going to go down 5 and over 1. And it's actually a dot that I already have, so it's kind of cool. And there you go. Looks like it's crossing at 1, 5. Okay, but just to be sure, we're going to check our work. So let's plug in that value. For x, we're going to plug in 1. And for y, we're going to plug in 5 and see if it's true. So this is negative 5 plus positive 5, and that does equal 0 on both sides. And then when I plug it in over here, 5 times 1 plus 5, does that equal 10? So that's 5 plus 5, and yep, that does equal 10. So I did find my solution to be 1, 5. Perfect. So I hope that this was pretty clear for you. I have one problem that I want you to try on your own, and it's to solve the system by graphing, just like we did in the last two examples. And then check your solution when you're done. So here are your two equations. Negative x plus 2y is equal to 3, and also 2x plus y is equal to 4. So let me know if you have any questions when you come back to class, and I'll see you then.